Hey there, welcome to Cloud on Air, live webinars from Google Cloud. We're hosting webinars every Tuesdays this March. I'm Soumya Kannan. I'm a technical curriculum developer in the Google Cloud Platform training team, and this is my co-host.
I'm Elaine Biddle, and I'm also a technical curriculum developer for GCP.
Brian Rice, our technical curriculum lead, has graciously volunteered to be our Q&A moderator. We want to answer as many questions as we can, so leave your questions on the webinar platform. We'll answer a lot of them live, and if we run out of time, we'll make sure to type out the responses to the ones that we don't get a chance to cover.
Thank you, Brian.
Today's webinar is all about learning how StackDriver features enable you to debug, monitor, trace, and enable logging in your applications that are running on Google Kubernetes Engine. This webinar will be relevant for cloud professionals building cloud-native applications on Google Cloud Platform. If you enjoy today's webinar, definitely check out the Developing Applications with Google Cloud Platform specialization on Coursera. At the end of the webinar, you'll receive a voucher to get started with the courses in the specialization. If you want to learn more about the training that we have to offer, check out cloud.google.com/training. All right, let's see what we have in store for you today. We'll be talking about cloud-native applications and microservices. We'll look at a couple of customer case studies. And Mylene here has lined up a couple of neat demos for us about microservices and StackDriver. We'll wrap up with some Q&A. Microservices seem to be the rage in software engineering today. And rightly so. Traditionally, monolithic applications were the norm. And with monolithic applications, the problem is that the code base becomes bloated over time. It can be difficult to determine where code needs to be changed, and packages can have tangled dependencies. The entire application needs to be deployed and tested, even if a change is made to a small part of the application. This increases the effort and the risk that you have to take when you're making feature changes and bug fixes. Microservices, on the other hand, enable you to structure your application components to match business boundaries. The code base for each service is modular. Each service can be updated and deployed independently without requiring your customers to change at the same time. Each service can be scaled independently depending on load. For each microservice, teams can use different programming languages and toolkits that work best for the problem that they're trying to solve. Well-designed microservices are loosely coupled at runtime. Tightly coupled components can make an application less resilient to failures, spikes in traffic, and changes to services. And intermediate components, such as a message queue, can be used to implement loose coupling, perform asynchronous processing, and buffer messages in case of spikes in traffic. You can use a Cloud Pub subtopic as a message queue. Publishers can publish messages to the topic, and subscribers can subscribe to messages from the topic. In the example that you see here, the order service can continue to publish messages to the message queue, even if the inventory service is down. And later, when the inventory service comes back online, it can retrieve all orders from the message queue, including the ones that came in when the service was down. That's pretty cool. Mylene, why don't you tell us about the microservices demo that you've lined up for us?
Sure thing, Soumya. So the microservices demo is a cross-platform application that demonstrates microservice best practices, some of them described by Soumya. The architecture of the demo microservices application was intentionally designed to provide as many microservices as possible It was also written in multiple languages, Java, .NET Core, Go, and Node.js, as she mentioned, so that different parts of the team can really write the code and the microservice based on the problem they're trying to solve. And it also exercises a number of different technologies. As you see in the architecture diagram, the microservices are roughly defined by the functions of an e-commerce site. The demo I'm going to show you uses a fake web store application called the Sock Shop, and it runs on Google Kubernetes Engine. Before exploring what it takes to debug and monitor the application, we're going to explore the application. In order to do that, I'm going to switch over to the console. And in the console, just get my mouse over here. I'm going to go to Kubernetes Engine. You can see here when we go to Kubernetes Engine that my Sock Shop cluster has been deployed. When I navigate to Discovery and Load Balancing, we're going to see about 14 separate microservices that have been deployed as part of this cluster.
That's pretty neat. So over a dozen microservices have to play well together in order for this demo to work well.
Absolutely. And again, like we showed you in the diagram, they're all written in different languages. So you could have, one team working on one piece and another with the other, and they all seamlessly work together. To get to the web page front end, I'm going to click here on this endpoint. And here we have our Sock Shop. So I'm going to generate some order points and some errors that I know exist so that we can really figure out what's going on with this application. So I'm going to go in here, and I am going to add these crossed socks. I'm going to look in my cart. And so here we see there's one pair of crossed socks. Let's say I had a customer report that when they added something to the cart and then updated the quantity to 0, and then clicked Update Basket, that it updated the quantity, but it still kept it in the cart. So obviously that's an error. We've generated an error.
Yep.
So I'll remove that, and we'll look into that later. And now I'm just going to add some more data points. I am going to add to the cart. I'm going to go back into my cart. I'm going to log in so that I can complete an order.
It's funny, there's a market for holy socks.
You never know. So if I go back in here, you never know. So if I go back in here, I'm going to click Proceed to Checkout. And I've now created one order. So I'm going to go back into here, and I'm going to add a couple more socks so we have a couple more data points. As that refreshes, I'll go in here, Proceed to Checkout. And I'm going to add one more pair of socks. I actually had a customer report that when they add the colorful to the cart, that it takes longer than the others. As you can see, there seemed to be some latency around that. So that's something that maybe we should look into later. So I'll go ahead and click back into the cart, Proceed to Checkout. And now we have 3 separate orders that we can look into in StackDriver. So with that, I will hand it back to Soumya. There we go.
Nice. So, you're probably sold on the benefits of microservices. You've been listening to the buzz in the industry today. Microservices have many advantages, but they bring a new set of challenges related to complexity, communication between services, latency, and debugging. Debugging, logging, and monitoring a distributed application can seem pretty daunting. StackDriver helps provide greater visibility and increase application reliability. You can monitor GCP and multi-cloud environments, identify trends and prevent issues, reduce monitoring overhead, and fix problems faster. StackDriver improves signal-to-noise ratio. Remember, you want to wake up your on-call support folks for real emergencies only. You really don't want to be in a situation where you find out from your customers on social media that your application is down. It's important to monitor the status of your application and services to ensure that they're always available and performing optimally. The monitoring data can be used to automatically alert operations teams as soon as the system begins to fail. Operations teams can then diagnose and address the issue promptly, ideally before your customers even realize that the application is down. Implement a health check endpoint for each service. The endpoint handler should check the health of all dependencies and infrastructure components required for the service to function properly. For example, the endpoint handler that you see here can check the performance and availability of storage, database, and network connections required by the service. The endpoint handler should return an HTTP response code of 200 for successful health checks. And if the health check fails, the endpoint handler can return a response code of 503 or a more specific response code depending on the error. A health monitoring agent, such as a load balancer or StackDriver monitoring, can periodically send requests to a health check endpoint. Load balancers use health checks to determine if an application instance is healthy and is capable of receiving traffic. If the health check fails beyond the threshold that you've defined, StackDriver monitoring can send you an alert automatically. Treat your logs as event streams. That's another best practice here. Logs constitute a continuous stream of events that keep occurring as long as your application is running. Don't manage log files in your application. That can get really clunky really fast. Instead, write to an event stream such as standard out and let the underlying infrastructure collate all events for later analysis and storage. With this approach, you can set up logs-based metrics and trace requests across services in your application. With Google StackDriver, you can debug your application, set up error reporting, set up logging and logs-based metrics, trace requests across services, and monitor applications running in a multi-cloud environment. All right, here's a customer case study. Buildertrend develops cloud-based software and mobile apps for construction professionals. They have tools for managing pre-sales, projects, customers, and financials. Frustrated by frequently slow performance, Buildertrend switched from a shared cloud infrastructure to Google Cloud Platform. The company now delivers more reliable performance to customers. StackDriver monitoring is a key component of their application, along with Google BigQuery and Google Compute Engine.
Great to hear of a customer who went all in and how it's helping them.
Uber's site reliability engineer, Ryan Chatford, explained how they use StackDriver for monitoring dashboards and policy-based alert management. Uber quickly created dashboards to visualize monitoring data for compute instances and for VPN statistics. Mylene, I'd love to see your demo about StackDriver monitoring, logging, and trace.
Absolutely. So like Soumya mentioned, StackDriver Trace is a key tool that helps you understand latency in your applications by showing you how long actual customer requests are taking through every step of the journey through a distributed system. There's a traffic generator included in the project that we actually give you a link to on GitHub, and it's sending traffic to our application, which is sufficient for Trace to provide more information about the latency. So let me go ahead and switch back to the console. There we go. I'm going to go back to the console. And I am now going to navigate to StackDriver Trace.
Hey, look at that. This application has a health check endpoint implemented, and you can see on the screen here that StackDriver is sending, doing a health check every couple minutes or so, and receiving data back. Pretty neat.
Pretty cool. So I'm going to switch to the trace list. And so here in the trace list, we have some information about the spans. So each span represents one of the steps that was completed during the processing of a request. So I'm going to filter it because there's a lot of information. And I'm just going to look at the orders. And if you recall, we made a couple of orders. If we click here on the span, we're going to get more information about what was happening in each step. If we scroll down and look at the timeline, we get more information about the steps of the requests that are happening both in parallel and sequentially.
So that's pretty nice, right? So you can visualize which of your calls are happening in a serial manner and which are happening in parallel, and even identify areas of optimization. So if you see that there's a bunch of calls happening serially, which you could instead do in parallel, then that would reduce the amount of time that it takes for you to complete a request. So really great insight into what's happening under the hood with your application.
Yeah, it really gives you a good overall picture from a lot of data points of what's happening in a timeline-based view in your application. So now that we've looked a little bit into the trace, I'm going to go over to StackDriver error reporting and look into that error that we tried to replicate that, let's say, a customer told us they encountered. So when we navigate to error reporting, first thing we see is an error. And I will, for transparency, I did generate the error a couple times before we started this demo, but we did generate it once here. So when we click into the error details, it's going to show you how many times did this happen. So obviously, if you were replicating something a customer saw, you could say, OK, well, I did it once. The customer saw it 15 times. We need to fix this. It tells you the first time it was seen and then the last time it was seen. Super helpful. So this is the one I generated just now. We have a couple more details up here. If you click on the overflow menu, it gives you the option to turn on notifications for the error group. That's really useful so that you can always monitor what's going on, and it's one click away. You also have a resolution status. With the resolution status, you can go in here, and for this error group, you can say, I've acknowledged it. Our team's working on it. You can say it's resolved. If you resolve an error group and then it crops up again, you didn't really fix it, then you'll automatically be notified that the error group you previously resolved has now been reopened. So now that we have that, we have a couple more details. If you look down here in the errors and you want to see exactly what was happening at the time of the error, I can click here on View Logs, and it's going to navigate me to StackDriver logging. And it's going to filter it down to the time when that error happened. A lot of things are happening, though, so this isn't super easy to parse through. So I'm going to filter to just the errors, because it's showing me all of the logs of everything that happened for all of the microservices. And as we saw, there's a handful, 2 handfuls. So here is our error. If I expand it, and then I look at the labels, it gives me lots of information about the error. And it's actually telling me that the error happened right here in this front-end pod. If I click here and then look at Show Matching Entries, it's then going to go to the advanced filter for logging, where it's showing me all of the errors that happened for that specific pod. Now, I also want to see what happened before and after the error for this pod. And since this detailed filter has already been filled out for me, I'm going to remove the severity of error, resubmit the filter, and now I can see here's my error, here is what happened exactly before the error, and then what happened after it.
That's pretty cool. So you don't have to wade through log files. Instead, you're able to quickly zone in on the problem area and try to understand what's going on with your application.
Absolutely. Cool. It's very powerful to do it this way. So now that we have some context around what's wrong, let's go back to that error. And so we're going to dive into the problem a little bit more by looking at snapshots. A snapshot captures the local variables and call stack at a specific line location in your source code. So when we look at the error details, you'll see that it actually tells you the exact line of code where this broke, right here. It's in the index.js file at line 165. So if I click here, it is going to redirect me to StackDriver debug. Wait for that to load.